Welcome in this session. And now today I discuss the new chapter electric field and Coulomb's law. After I want to say about of the COVID. All of you know very well at present very crucial stage in the world. So all of you follow the COVID protocols and maintain the distance to each other and use the wash off and sanitizer and aware to all friends and in groups. So now I started the new topic Coulomb's law and electric field. So first one thing is here topic is electric charge. What is the meaning of electric charge? In the starting of the 2500 years ago, Mr. Thales, one Unani philosopher, Mr. Thales, was found a material amber and rubbed with wool, then some attractive property will be generated in there. So that are studied by Mr. Thales in the initial stage. After some time, about 1600 years, Mr. Gilbert also observed that some other material like amber, glass, ebonite, and sulfur. These materials, when rubbed some other small particle, pieces of particle like paper and straws, then that type of property that being attractive and repulsive will be generated from there by rubbing this one. So that are observed Mr. Gilbert in 1600 years. So initially he said the charges are two types. One is when you rub glass rod rubbed with silk, and another is ebonite rod rubbed with cat skin. So initially, when glass rod rubbed with silk and generate a positive nature of charge, and ebonite rod rubbed with cat skin, that means negative charge will generate on there after rubbing. So that two phenomena which are observed Mr. Gilbert by an experiment he explained. He first he take a glass plate rubbed with silk that we passed charge there and connect with a thread, and another arrangement rubbed with silk and this glass plate. So same charge on there when brought to near this one as arrangement. So these observe they both are move away. Away that when you can see both are the light charges, due to that they are repelled. So you take another experiment. First one, you take the glass plate rubbed with silk, that means switch on there, and another one rubbed with cat skin with ebonite rod. So there are different type of charge respect of first, and when brought to near first one, then that will attract toward. That means you can see some phenomena will change with respect of initial. So you can say that attractive property will be generate from in between, and here repulsive property. So by putting that in, you can say that so both are the like charges, that means similar, and here both that attract to each other. That means you can say that both are different polarity, different type of charge. By this reason that are attract to each other. So Mr. Benoit, Mr. Gilbert was observed initially this one, and concluding that he says the charge has two types. One is positive charge and next one is negative charge. So after some time, someone observed the force acting between these and this one, that may be repulsive and attractive nature. So that one observed by Mr. Coulomb, and he gives us one law, that is Coulomb's law. Coulomb's law. He said when two charges are separated to some distance, like small or in a medium, like that is vacuum or air, and its magnitude is Q1 and Q2 on there, both are like charges and both are stationary. So influence of that to one force is acting in between them. So as far as Coulomb's law, he said force is directly proportional to the product of charge on each and inversely proportional to the square of distance between them here. So when you combine these rules and gives a new form, and like this one, so F become 1 upon 4 pi epsilon naught k q1 q2 upon r square. Here k is the dielectric constants that represent the medium which are present in both the charges. That means you can say if a medium is air or vacuum, that means value of dielectric constant is 1. So this become 1 upon 4 pi epsilon naught q1 q2 upon r square. Here epsilon naught is that means epsilon 0 also you can say is a perpetuity of free space. So this is the Coulomb's law, and the value of this constant is 1 upon 4 pi epsilon naught is 9 into 10 to the power 9 Newton meter square per Coulomb square. This is the value of this constant, that means 1 upon 4 pi epsilon naught. Its value is 9 into 10 to the power 9 Newton meter square per Coulomb square. You know very well. So generally in examination, ask the question what is the dimension of this one, and unit is, so unit is also here atom. So you can see Newton meter square per Coulomb square, and how to find the dimension of this one. So you know dimension of Newton, that is ml t minus 2, that is force, and meter square, that is a length square. So L square, and Coulomb square, that is Coulomb. Q is equal to IT, that is a AT. So square, that means A square T square, that become. So concluding, you can write M L T square, that is T minus 4, and L square and L, that is L cube, and A minus 2. Once again, M L1 or 2, that is L cube, T minus 2 at the denominator, T square that move in upward, so that become T minus 4 and A minus 2. This is the dimension of 1 upon 4 pi epsilon naught. It's a very important question for examination and the competition point of view. Okay. Also ask the one question, what is the unit and dimension of epsilon naught? So from here you can guess, you can see the epsilon naught is reciprocal of that one here. So its unit and dimension both are the reciprocal of given this one. So unit of epsilon naught is here you can see Coulomb square Newton meter square, because of reciprocal of that, so it becomes this one, take this shape, and dimension is m minus 1, l minus 3, and t to the power 4 and a square. So this is dimension of epsilon naught. So very easily you can find out the dimension and unit from this relation. So there is no any problem. Okay, beta. So now electric field. So first one thing very important here, before I explain the charges like plus that mean emerging of lines of force from any body that is positive. Positive charge will emit electric lines of force like this one, and negative charge will absorb or like this one, are restored from there. So this is the nature of positive and negative charge of electric lines of force in this situation that are emerged from there and their ends, and that you can say also absorb that. So when combined, two charges are taken for a short in distance, so electric lines of force will generate like this one. And when the electric field will be poor, so like pattern will generate like this one. Like this one. Okay, this type of pattern will be generated. This is the electric lines of patterns. So I hope there is no any problem at all. So this is the lines of force. That lines of force which are moving around of that charged body. So you can say that is depend the electric field of that charged body. For example, if my hand is moving around me like this one, so we can capture all elements which are present in covering areas. That means you can say this is the electric field of my hand. So same as here, this charge particle will capture, that charge particle will influence to other charge particles which are in coverage areas, so that represent the electric field. Okay, so now electric field E is equal to force upon experimental charge. So in a unit charge which are in a place in an electric field, there is ratio of acting force on experimental charge known as the electric field. This is the vector and you can see here E is equal to F upon Q naught. So if Q naught is 1 Coulomb, so this become E is equal to F. So in this situation, when the unit charge will place in electric field, then the active force on any experimental charge that are experienced, that is equivalent to the electric field of intensity. Okay. So unit of electric field intensity is Newton per Coulomb. Newton per Coulomb. Unit of force in Newton and Q naught is Coulomb. So unit of electric field intensity is Newton per Coulomb, and its dimension is, so you know, force, that is a ml t minus 2, and the Coulomb, that is a at. So this become m l t minus 2 and minus 1 3, and a minus 1. This is the dimension of electric field intensity, ml t minus 3, a minus 1. This is the dimension of electric field intensity. So I hope there is no any problem. By using that method, you can very easily find out the all results and dimensions, units, and some rules are also clear. And here one important points are come to the new knowledge. And as far as Mr. Thales is the name of amber substance which are having some properties which, when we rub the pipe to the old wool, then the attractive and repulsive property will generate from there. And after some time, Mr. Gilbert also observed that some other materials like glass, carbonate, sulfur, and amber, when these are rubbed to the pieces of some paper and straws, then some property will generate, requiring the properties of attractive and repulsive that are observed by Mr. Gilbert. So after this one, this research, that observation, Mr. Coulomb, that are experiencing some force which are acting between the that charge bodies. So he explained our force is acting in between that charge body. That is that force is known as the Coulombian force, and he explained this one and gives one very important rules: R is 1 upon 4 pi epsilon naught Q1 Q2 upon R square. So I hope there is no any problem. All of them very clear. So there are no any doubts. If you have any doubts about that topic, you can give the message to my channel. Okay, thanks.